So I want to give you guys a few minutes to set it up. So let's do this first part right here. I'm going to give you a few moments to do that, and then I'm going to review that part. If you finish early, just keep working, but I want to check in with you partway to make sure you're on the right track. So why don't you guys take a few moments to try this Classwork 1 first. First thing I would say is that A is always the lower limit, so we want to put a 0 here. B is the upper limit, so we're going to put a 2 here. Our delta x is going to be b minus a, put that in parentheses, over n. So that's going to be 2 minus 0 over n, which is just 2 over n. I want to use the right endpoint, which is that xi star that I chose there. My a is 0. I'm going to be pedantic and put in the 0 plus I times 2 over n. And then I'm going to write that just as 2i over n. My f of xi star is going to be 3 times xi. I'll write it in steps. 3 times xi star plus 1. In this particular case, that's 3 times 2i over n plus 1. That's equal to 6i over n plus 1. Is there any questions about this so far? All right. So now when I put it together, my Riemann sum is going to be the summation of f of xi star, which we just calculated was 6i over n plus 1, parentheses, times my delta x, which is 2 over n, like this. And we're going to go as I goes from 0 to n. Okay. So I'm going to let you simplify this and then finish the rest, and then we'll go over it in a moment. So you guys continue this. Let's do this. So we got our Riemann sum over here, and I want to simplify this. So this is going to equal to the limit as n goes to infinity. We're going to have this summation as I goes from 0 to n. You're going to have 12i over n squared plus 2 over n. Okay. And then we want to split this up. So we can write this guy as the limit as n goes to infinity. This is the summation. We can factor out the constant first. So I'll write a couple lines to split it up. So it'll be the summation as I goes from 0 to n, 12i over n squared plus the summation as I goes from 1 to n, 2 over n. So I just use that sum law. This guy I could split up further. So this would be the limit as n goes to infinity. I could factor out the constants, and anything other than I is treated as a constant. So this will be 12 over n squared times the summation as I goes from 0 to n. This is summation of I plus 2 over n summation as I goes from 1 to n times 2. Okay.
Professor,
Yes.
I'm just curious for the second one. Like, why is it like I is equal to 1 and the first one is I is equal to 0?
It's I equal to 0. You know, that's a good question, Jason. I think actually I want my I equal to 1. So I just think I have a typo and all that because we're cycling through the number of rectangles. So I always starts at 1. So I think I just made a typo on this worksheet. So maybe we could fix that for me because we're doing n rectangles. So we're counting the number of rectangles. So we should have ones there. Thank you.
Professor,
Yes.
would that also change the value of A as well up top?
A,
Or would A still be 0?
um, A is still 0 because A is tied to this this lower limit here.
Okay, thank you.
Yeah. So because we're using the right endpoint, the very for the very first rectangle, it's not going to be that that left endpoint. It's going to be the right endpoint. So the very first xi star should be non-zero. So the very first xi star should be 2 over n. So thank you, Michelle. Yes, this is a 1, not an I. I factor out the 2 over n like that. Okay. These guys are both starting at 1. So then this guy becomes the limit as n goes to infinity. You got 12 over n squared, and then you're going to have a n times n plus 1 divided by 2. And then for the second term, we're going to have a 2 over n times n, because when you add 1 to itself n times, you get n. So one of the things I want you to notice is that the powers of n here cancel out. And the total power of n here is 2. And the total power of n here is 2 as well. So we could cancel one of these with one of these. And when we simplify, we're going to get the following. We're going to get the limit as n goes to infinity. We're going to have a 12 over 2. That's the constant part. We'll have times n over n plus 1 over n. So that's looking at this n plus 1 divided by n. And then the last part here is just plus 2. So, so what do we notice? We notice that the n and the n cancel each other out, right? We got the limit, we got 1 over n, so this is going to 0. So in the end, we're going to get, this part here is 1, right? So in the end, we get 6 times 1 plus 0 plus 2, we get 8 units squared. Those of you that